Hello. This is the hyperdevlog. Sort of a mix of chatting slash live coding. Uh, really my first time doing this, so I'm not sure what I'm doing or what all the knobs to click and poke at. Uh, I am live streaming both Twitch and YouTube right now. So, took a while to get all the infrastructure in place, but now here we are. What's my plan for it? I don't know if I really have a plan. A couple weeks ago, I wrote a sort of essay on my website, and I was talking about how I wanted to start developing my own technology. And so I guess that's what this is I'm going to be taking the opportunity live stream slash live code, be developing that technology. Whatever that technology is. I don't really know at this point. But we'll see. I do have a couple of goals. Write down a couple here. So, what do I want to develop? Well, on the post on my website, I talked about how I want to develop my own hyperstack, which is just like a web stack to like that already facilitates the common operation of startup or product or web application, whether that's signing up users, collecting data. That'll be part of it. Start idea. Bit of admin dashboard. And then I'm not really sure where to go from there. I know I'm not going to be doing this in I've done a lot of Ruby tutorials over the past 1 or 2 years, and it's a great language, but I'm more interested in learning other things. Other things have caught my eye. So I guess what I want to learn is I mentioned this on that post on my website. I want to learn Elixir and yeah. So I've never really learned Elixir before. I don't really know much about it. I've read a little bit about it. I've read some books and tutorials and stuff like that, but I've never actually sat down with my hands on keyboard to build an application in Elixir or for laying OT, stuff like that. Likewise, C programming, I don't really know much about it. I know C a little bit. I know the syntax, like if, do, while loops, stuff like that. But I've never actually sat down and actually programmed an application, a full-blown application C. Like Elixir, I've read a lot about it. I've watched tutorials, read a few books, but that's about it. So, a lot of this will be learning stuff, and a lot of it will be developing a sort of hyper stack. Not necessarily in that order. I don't know. Anyway. Let's get started, I suppose. Right out of this. First, I guess I will. Well, I kind of want to go look at this. I want to start with learning Elixir. So let's do package add Elixir. Okay. And then I'll create a directory for my Elixir experiments. Let's see. And I would say the best resource to learn Elixir is probably just the Elixir Lang website. So yeah, they have like an entire whole thing here. It introduces things. It gives you the basic types, goes over pattern matching, control flow, modules and functions. Yeah. So I'm not going to go through this entire thing. Mostly because I think that would be boring. But since I've never actually done this before, I've opened up the interactive shell for Elixir. And yeah, let's just do a couple things. Cool. Then I can concatenate stuff. And if you want to run a script, put out of that. io.puts. And on Elixir. Cool. And then go to the next page. Basic types. Do I really want to go over the basic types? The only thing I think I will have trouble with is the difference between lists and tuples or tuples. I'm not really sure how you pronounce that. Tuples. I always pronounce it tuples. I've heard people pronounce it tuples, and then I get confused. Let's see. Oh, this is interesting. So, a lot of other language vision, it doesn't automatically would think that this was 0.5, but usually, like say, I guess we could try this in Ruby. Yeah, these are integer types. You're doing operations between integers, so the result is an int. But Elixir doesn't do that. Which, okay, fair enough. Excuse me. Let's see what else. So you can use these operations div or remainder to sort of do integer operations for division. So okay, yeah. What else is there interesting in the chapter? No, let's also use syntax to access documentation. Finds the H function. Okay, cool. Let's see what this does. I typed hdiv. What does guard true mean? Yeah, that's the whole thing about learning a new language, especially trying to develop an application in a new language, is that you don't know what you don't know. So you kind of just have to learn as you go, obviously. But you have to learn the best practices and hope you're not making a mess out of a project that you wouldn't normally if you were developing in a language that you actually knew. But that's kind of part of the fun here, I guess, is figuring all of this out for the first time, learning, and so on and so forth. So, well, we learned about H, and going over atoms now, which I guess is similar to symbols in Ruby. Yeah, pretty much the same. Yeah, exactly. Which I suppose is fair because the creator of Elixir basically was a Ruby core developer, I believe, and just took some ideas like syntax and things like that and applied it to like the Erlang language in order to come up with Elixir. Yeah. Let's see. I don't really care about that. Strings. Okay. Strings in Elixir are delimited by double quotes. That's interesting. In Ruby, they can be either or. So if I do this, hello, changes it to a double quoted hello. The only time this ever comes into play is string interpolation. If I do hello, and then say, well, let me assign a variable test equals world, stuff like that. say hello test. Then it interpolates that string. But if I do the same thing with single quotes, it does not do that. Okay. So there is string interpolation here. Oh, there's string interpolation here as well. Oh wait, no. Oops. I used the wrong argument. There we go. Let's see. Puts. Get the number of bytes in a string. That's pretty cool. Notice that the number of bytes in that string is 6, even though it has 5 grapheme. Okay. I just think it's funny that they're in word grapheme. Haven't really encountered that outside of college. Anyway, let's go to anonymous. And assign a function to an argument. What do they call it? I guess this is binding. Let's see. I mean, I guess I could just copy this. Hold on. Add equals function a comma b, a plus b, and then if I do a dot 1 plus 1, 2, a dot 1 plus 10, 11. Cool. That's not really what I'm interested in. Actually. That's not what I'm interested in, actually. Skip around a little bit and pattern matching, additionals, lists and strings and stuff. No. Let's see. Streams and enumerables. Oh, okay. Let's go to processes. Okay. So all code runs inside processes. They're isolated from each other, run concurrently, and communicate via message passing. Okay. So I can spawn and add 1, 2. That's weird that whenever I do like oops. I was trying to exit out of that, but whatever. Fine. So if I do add function, yeah, so it's weird whenever I parentheses and like I close that parentheses, it kind of goes back to opening parentheses. I guess that's a quality of life kind of thing. A little quirk that I guess it'll take some getting used to. Anyway, so let me spawn. This is gonna take some getting used to. What do I do if I want to like if I type some stuff and then I want to just break out of that line? Because if I do control C, like if I go to IRB and type some stuff that I don't really mean to, I can do control C to exit out of that, go to a different line, but it doesn't seem to be the case in Elixir. Same thing with the shell. If I type some stuff that I don't mean to, I'm like, this is too much to just delete. Then I can just control C and it'll go, but it doesn't do that in Elixir. Interesting. Let's see. So let me just define that function again. And then do spawn. Can I just do function add? Okay, cool. Seems like something happened. Turns a PID. Does the do the Ruby thing? No, it doesn't. So in interactive Ruby, if you have like an argument or like an output of previous line, you can assign that to a variable by saying the variable name equals underscore, and that assigns p to 123 or whatever. But that's not the case in Elixir. So this will definitely take some getting used to. I guess I could just do this id and then that process.alive. Okay, so this is kind of the same. Have predicates with question marks. Cool. Yeah, what's my id? 107. Okay. And then okay. What if I do like will this work? Okay, it did print out 3. Now here we get to the message passing stuff. Send and receive. We can send messages to a process with the send /2. How do you read those? Because I know that this refers to the arity function, which is number of arguments. But how do people read this aloud? Send /2, send 2. Anyway, and receive them with receive /1. Okay. Send to self this tuple, and then receive the message. Okay. So let's just let's try that out. Okay. Now let's do IO dot puts. Cool. Let's try. I guess I have to do this again and again. Cool. Let's see. Send messages process. I mean, I think I kind of get the idea now. Okay, so I'm just gonna keep going. Linking. The majority of times we spawn processes. Elixir, we spawn them as linked processes. Parent process is still running. I guess the parent process being the current process. So if we do yeah, let's try that. Cool. It started a new process, which is now 128 instead of what was it earlier? 107. Okay. Tasks. I don't know if I want to go through this entire thing. Because like I said before, I have read a couple of resources, including this one, in the past couple of weeks. So I'm not exactly sure if it's interesting enough to like see me go through this entire thing. So state. So this might be interesting. So start state. Talked about state so far in this guide. You are building an application that requires state, for example, to keep your application configuration. Or you need to parse a file and keep it in memory. Where would you store it? Process. We can write processes that loop infinitely, maintain state, send and receive message. Okay, yada yada yada. So let me exit. Oops, okay. Let me define a def module. I guess I'm just gonna do a counter. And def start. And I'm not going to do a key value store, so I guess I'll just start with 0. And then and again, this is a very naive interpretation. So receive. Okay, so I actually do want to receive some sort of messages. And then we could say receive, do. And then if we pattern match on the message, add, maybe. I don't really know if this is correct. And we map.put map value. Say count value. So I'm thinking that we're passing an empty map with the count of value. And I want to modify this map. Well, I mean, everything's mutable, but I'm sorry, everything is immutable, so I'm not actually modifying it, but I'm creating a new map and putting value plus map.value. Maybe. Maybe. Let's see how this works. Oh, and a counter, I don't really want to add a value. I just want to add +1. And then I need a way to retrieve the value. Oh, I also need to oh, this is correct. Send caller. Parentheses. Send caller app get. No, I don't know if this is correct. Maybe I'll just send in 0 value. This seems a little complicated. So I'll just continue map.value +1. And then if I receive a message of get, I'll send the caller the value. and then I will loop the value. Okay. And this is because we're doing tail end recursion, so I need to call loop again. Recurse that function. Oh, this is wrong. Okay. Okay, give it a try. So I just call IEX. Color is unused. The variable is not meant to be used. Prefix with an underscore. Oh. Now, why is that? Okay, let's give it a try. So what about put? Let's send a put message. Send that PID. I guess I can just, right? Yeah. I don't. Wait, no. I need the caller for here. But yeah, I'll change this in. All right. Maybe. Is that what it's complaining about? Okay, that seems fine now. So you can start by doing pattern matching on OK, getting the PID, counter.start link. Gotcha. And then let's send a message. Increment. I guess I send a tuple. Okay. Yeah, I guess that makes sense. And I'll do that a couple of times. And then I will and then I can send to the PID, get the value, and send it to the parent or myself. Okay, and then I call flush. Okay, yeah. I incremented it 3 times, and so the counter is at 3. This is actually pretty nifty. Notice how the process is keeping a state and get and update this state by sending the process messages. In fact, any process that knows the PID above will be able to send it messages and manipulate the state. In fact, it is also possible to register the PID, giving it a name, and allowing everyone that knows the name to send it messages. So I guess if I do process register PID counter, okay, and counter. Whoops. That didn't work. I didn't send myself. Okay, there we go. I wonder why that didn't throw an error. Because there wasn't a pattern match on that. So that's a little odd, right? Anyway, I don't want to harp on it too much. Using processes to maintain state and name registration are very common patterns in Elixir applications. However, most of the time, we won't implement those patterns manually as above, but by using one of the many abstractions that ship with Elixir. For example, Elixir provides agents, which are simple abstractions around state. I'm not really sure I'll be using agents that much. Maybe I will, maybe I won't, but okay. I/O and the file system. These require import module attributes, structs, protocols, comprehensions, digitals, try, catch, and rescue. Optional syntax sheet, Erlang libraries, debugging, type specs, and behaviors. Where to go next? And then introduction to mix, agent, gen server, supervisor, and application. Let's go to gen server. Okay. Start link. Okay. This is actually just building an application, or I guess key value store. This is what you get for skipping around, I guess. I kind of remember this from my previous reading, but I don't really recall too many details. Yeah, it's a key value store, and organizing those key value pairs into buckets, and those buckets across multiple nodes. A simple client. Anyway, okay. Gen server callbacks. Gen server is a process that invokes a limited set of functions under specific conditions. When we used an agent, we would keep both the client code and the server code side by side. Code above would be two separate functions. Oh, I see. So this is the public function, the public facing function, to obfuscate the use of that you're actually using processes behind the scenes. But then that function calls genserver.call. You're sending a message to that server, this bucket, whatever it is. And then this is pattern matching on this specific message and then replies with, okay, I received this, and here's the new state, I believe. Yeah. AV.registry. Okay, so this is supposed to be a registry for different buckets, I think. Yeah. Okay. So there's a lookup message, a create message, and if the registry already has the name question, then don't do anything. Otherwise, create a new key value bucket. Okay, well, I don't really want to continue going down this because it seems a specific application. But this seems like, I mean, I'll skip around, I guess. So supervisor and application. Yeah, I'm gonna quit out of this. Let's see. Exit. So, what to do next? I don't think I learned the whole of Elixir in just 1 hour. But that was certainly fun. But still not enough to get started on this stuff with just that piddling little amount of knowledge. So, thinking out loud right now. I think I'll take like a 5-minute break. Back. All right. Let's. How do I get this started? Hello. I am back. Um, now that I look at this, I look at these notes, it looks a little bit incomplete from what I was thinking. Um, so this has to do with, I guess, web development. That's primarily because, I, professionally speaking, I only work in web development. Um, and that basically means, web web pages, communicating with backend servers in some way, provide some value to a customer, um, or business unit or whatever I'm doing at the time. But I'm also interested in developing technology for mobile development. And that's part of the reason I want to learn C programming as opposed to, I don't know, Swift or Kotlin or whatever other kind of native languages there are. Um, I'm pretty sure that you can do Android development purely in C by calling into the Java bindings, as it were. Um, but I'm not sure if you can do the same with iOS development. I'm pretty sure you'll still need to do like some Objective C. Um, but that's what I'm interested in. What else? What else was I gonna say on this? Anyway, um, so yeah, I want to learn mobile development, and that's why I want to learn C programming because C, like all architectures speak in C, so to speak, I guess. Um, and I've never really actually, yeah, like I said, I've never actually developed a program or application in C ever, professionally or otherwise, like hobby, as a hobby. And I'm not necessarily looking to like I want to learn like graphic. I guess this should go into the graphics programming, but not necessarily games programming. I'd like to develop my own UI kind of thing. Which is basically, I mean, if you think about it, it's basically boxes and stuff with some fonts, simple stuff like that. Um, and what else am I interested in doing on this hyperdevlog? I mean, part of the thing about speaking that you kind of forget. Well, I kind of forget what I wanted to talk about uh, while I'm talking, and then when I come back several minutes several minutes later, I I, I remember. Oh, I wanted to talk about that, but then the moment has passed. Uh, so um, so you might be asking, why don't I just do like mix? I don't know the exact commands, but mix.phx.new and start a new project that way if I want to do all this stuff. And I would do that. Like, say if this was not, if I wasn't learning Elixir, and if I was doing Ruby, if I was doing all this in Ruby, the same reason I wouldn't use like the Phoenix framework or anything like that has to do with my thoughts on stability Um, what do I mean? What do I mean by that? So there's a guy called Unix Shike. Uh, and he or she, I have no idea, probably he, um, lays out my thoughts on this a lot better than I could. So I would encourage you to go to his website and look at this article. What is it called? Framework. Using a framework can make you stupid. Well, I don't believe that. Let's see. What else? Where is it? That's. I guess I'm just going to go through this one by one. Yeah, like you can see, he's pretty opinionated. Oh, right, this one. How to write software that will keep working for decades without problems. And the problem is that I mean, I don't know much about the Elixir ecosystem. I do know a lot about the Ruby ecosystem, and um, if you're going to be doing web development, then the dominant web framework is Rails by a wide margin. Like it's not even close. Like the other kinds of web frameworks out there, Sinatra, Nabi, um, what else? I don't know. I guess Rack. That this is my favorite. Um, Technically, it's not a web framework, but I consider it as a web framework. And all of these other web frameworks are based on Rack, so it kind of wins out. Anyway, I already have a video about why Rack is the best Ruby web framework. That's not the point. The point is that even these other web frameworks, um, which I guess would be the equivalent of Phoenix in Elixir. So if you have these web frameworks, and if you want to build a stable application over several years, um, you're not gonna you're gonna run into problems when you use kinds of frameworks, because these frameworks are not stable. They change, um, like I won't say frequently, but they change often enough that there's pain associated with there's pain associated with developing a web application over multiple years with these frameworks. And because these APIs change or these interfaces change, that means your application has to change to or match those interfaces. And knowing nothing about Elixir or Phoenix, I can safely say that the Phoenix interfaces, Phoenix public interfaces, will probably change sometime in the future. Um, and if I want my own if I want my web application or any software that I develop to be stable and work for years on end without having to maintain uh, the interfaces in my application and framework, then what I found is to use a interface that is stable. And for the most part, Rack has been stable for a long, long time. I do think actually no, that's probably not true because I believe they introduced a breaking change. The Rack core team introduced a breaking change in Rack 3.0. Don't quote me on that, but I believe that is true. But for the most part, not much else changed. Even Ruby changed. um, like from Ruby 2.7 to 3.0, the way that keyword args uh, that changed. The way that keyword args were handled changed. And I know several projects that I was part of that had to undergo painful maintenance work to upgrade from 2.7 to 3.0 uh Ruby wise. And you may be wondering, well, if it's so painful, then don't you have the option of not upgrading? That's a silly response, because uh I'm sure the teams of the projects, and of course of um work very hard to make sure that their code is secure. But no matter how hard you work, bugs will creep into your code. And you don't upgrade your software. Like if someone decides to keep saying, I don't know, Ruby 1.9 because the pain of upgrading from Ruby 1.9 to Ruby 2.0 or to Ruby 3.0 is just too much, then they will quickly find that their software is exploitable by outside attackers. Because I mean, I'm just thinking about it from a human perspective. Um, Obviously, there are people still maintaining Ruby 1.9 and 7 and Ruby, but even so, the amount of work make sure that each of these versions is secure is massive. And I'm pretty sure even there are end of life requirements for the earlier versions of, like, I know that Heroku doesn't support certain versions of, they only support like the latest stable versions of, and I may be wrong about that, but I doubt that there are a lot of vendors that support Ruby 1.9, for example. And so all that to say, putting your faith in a framework to remain stable and continue working the same way year after year after year, when if we're thinking about it, you know, this kind of stuff, this will always be the same. This stuff won't change. What will change is uh the business value of product or application. That can change, but this stuff never change. This has been the same for decades, at least as long as I've been programming. On the at least as long as I've been programming, I'll just say that. So that's why I prefer to go down as low a level as I need, rather than rely on web framework. Now that may change. I mean, they're useful. Rails, Sinatra, Hanabi, though they're useful in as a, I believe they're useful a couple of cases. For me personally, I believe they're as a learning exercise. So I can look at the code and see what's going on and how other programmers are developing technology for web. And then I can use those things back here when I'm rack and working on my own thing. Oh yeah, I forgot to add Rhoda. uh, um, put that over Nabi. I actually think I think Nabi actually wrote a back end. Anyway, um, and so, where was I going with that? Kind of lost my train of thought. Anyway, that's why I like to use Rack. I use these frameworks as sort of a learning exercise, and I guess if you are um, an individual programmer or a small team or a startup, I guess, and you really want to move fast and spin up an idea in a very, very, very short amount of time, it makes sense to use a framework. Whereas it makes sense to use a framework in that case because there's a team that have developed these frameworks that have already done a large part of the legwork for you. But if I develop my own technology, develop my own hyperstack, then that will be a moot point. um, so anyway, that was a pretty long tangent. So that's why I'm not going to be using a framework. I do. There are a couple of things that I like about Phoenix. What? Well, the only thing that comes to mind is Phoenix Live View, which I believe, if I understand correctly, they embed a they embed some JavaScript into the browser to open up a WebSocket to your server, and then they they send they send updates down that WebSocket connection to the browser, and so sort of um, it's sort of well, I don't know if it does this, but it kind of obviates the need for a single page application or a framework for that, like React or Vue. So that's interesting. I'm probably, like I said, I'm probably not going to use Phoenix for my own hyperstack, but that's an interesting idea. And languages, a lot of different languages have adopted this idea for their own. Like I think there's a similar live view type thing for JavaScript and for Python, and maybe I don't actually know if the uh, that has matured a lot in um, and it doesn't even make a lot of sense because the currency in Ruby is not very well developed. I know there's a person called I don't know his exact name. Uh, GitHub username is iAquatics, and he developed several libraries that help with concurrency. Um, but still, it's not very well developed. Kind of why I'm moving away from Ruby in my personal projects and moving more towards Elixir. I mean, I still program Ruby professionally. Um, anyway, this is a long-winded way. I don't know why I started. I wanted to update. So I wanted to update these notes. That's right. So I want to do web development on my hyperstack, and I want to do mobile development. So that means Android and iOS. And this is an interesting thing. Oops. This is an interesting kind of thing because back in 2012, um, mobile devices were becoming far wait like very very widespread, and they were overtaking the it looked like they were going to overtake the desktop as the primary device to browse the internet with. I mean, nowadays it's kind of 50-50 between desktop and mobile devices. But at that time, people were seriously thinking, "Oh, this is gonna take over everything. Everyone's gonna be using the internet. One of these." That's why things like responsive websites and stuff like that started coming about. Uh, but nowadays, I mean, it kind of fluctuates here and there. nowadays, no, I don't think the desktop is going away time soon. But likewise, I don't think mobile devices are going away anytime either. Now, personally, I've already made a video on not going to be smartphones in my daily life for the reasons I articulate. Um, but I do want to learn mobile development. Simply because I mean I've never learned it. Yes. Uh, I like learning, and I think that's the only reason. Those are the only reasons to learn. So anyway, um, oh, so what else? Um, okay. Let's see. Actually, let me go back to my notes. Um, I'm not really sure where to go from here. I mean, I thought, I mean, I wanted to, I knew I wanted to live stream live code, but I don't know if I'm proficient enough in Elixir to do that. Without some sort of a plan. Um, so I guess this is a, let me just devlog and I guess my thought was that by developing this out, developing all this stuff through live streaming, that um, I would actually do it. I have a lot of it's pretty difficult to code in my off hours unless I have something else like some external factor motivating me. Um, yeah. Anyway, so if I'm not going to be using Phoenix, I guess what would I be using? I guess I could let me check hex.pm, which is the package manager for the Erlang ecosystem. Right. So I know there's a plug which is similar, I guess, to the similar to the rack in Ruby, maybe. And that was my impression. Is this not okay? Compose web applications with functions. Go to the documentation. Where am I? Okay, hexdocs.pm plug read. Plug, you need a web server and its bindings for plug. There are two options at the moment: Cowboy and Bandit. Now, I know Cowboy is older and more widely used. As you can see, there's a 2.0 here. It's gone through some iteration, and then there's Bandit that's 0.6. I don't really know how to evaluate which one is better at the moment, so I'm gonna skip that part. Let's see, hello world request response. This is a minimal hello world example using Cowboy web server. Fix install. Okay. my plug, import plug.const, initialize with these options. Yeah, so this is fairly similar to rack in that you send raw responses, but it's not similar in the fact that you. So what I'm thinking is you compose responses, like in rack. I'll just use this as a scratch pad. In rack, you have like you have a call method with that passes in an environment, and in this environment you have like, I don't know, several kinds of keys. I won't go into that, but what you need to do is you need to return back an array with three things inside it. One is an integer, which is the HTTP response, and then a hash or dictionary of the headers. So here we could say content type, and then text plain. So similar to this here. And then the third thing you need to return back is an array of strings. And so you would say hello world. And then this is, I would say this is functionally equivalent to this. Obviously, there's a lot more going on. Like you need to like a config.ru. You need to like say use sort of middleware, and then run your application, stuff like that. I mean, I'm probably glossing over a great part of what goes on. I need to like. But here's the thing: when I'm programming, I don't actually know everything. I don't have it all in my head or memorized. I frequently go back to my old notes or old code to see what I did, just because I can forget things. Anyway, so that's it. So it looks a lot like this. I mean, obviously, this is a more functional way of doing it. So it's not totally the same, but it looks similar. Okay, and then you start the logger, you start a web server for plug cowboy, or you start the cowboy web server, and then have a supervisor that is linked to that web server. So like if this plug cowboy web server fails or the process fails, the supervisor will catch that and restart the web server. And, okay. I can probably like, it says I can just copy this, right? Okay. Let's see. So if I do what, Elixir web server.exe, shall I install hex? Yeah, okay. Shall I install rebar 3? Okay, fine. I needed to build dependency telemetry. Okay, what is it installing into my machine? .mix archives. Okay. If I go here. Yeah, okay. I might change this up a little bit, but I'll leave it up for now because usually I like to like use the XDG specification, but it's fine for now that everything's in here. Like, I don't like to pollute everything here on my home directory. But this is a virtual machine, so I don't really care that much about it. If I do web post port 4000, okay, yeah, it just sends back a hello world. Cool. And here's a WebSockets example. That's pretty cool. So you have an Echo server here and a module, a router. Oh, interesting. Okay, so you can route requests by using the plug router and close out of this. This one doesn't use the router. This uses a plug.connection. And then it uses the web server, which uses that plug. I wonder, can you? This is probably the case, but you could probably stack plugs on top of another, probably. Okay, so this is an Echo server. What is this? So it's not using any sort of, like, it's not using Gen server or, but it's handling pings. Okay. Okay. And then where is that being used though? Where is Echo server? The router is opening up a WebSocket to this endpoint. And it's opening up a listener. Okay. I'm not sure I understand it. Supervised handlers. On a production system, you likely want to start your plug pipeline under your application supervision tree. Start a new Elixir project with --sup flag. Add both plug and plug cowboy as dependency. Mix.exs. Then my application. Hey, where was Echo server? Oh, here we go. Okay, so. Oh, I see. Get web. So this is the WebSocket connection. Sorry, I'm just jumping all over the place because thoughts occur to me and then I get lost in the weeds. All right. Anyway, let's supervise handlers again. Okay. So we have a module for myapp.application. Use application. So this is an OTP thing. That's what it looks like, at least. Let's go there. Module for working with applications, finding application callbacks. Applications are the idiomatic way to package software in Erlang OT. Okay. I think I recall this in the Elixir getting started documentation. So when you start this application, have your children, have some options. So you're starting a supervisor with this children. Okay, so you're, yeah, okay. So this is your web server, and you're starting that here. Now, what's the difference? Oh, I see. So yeah, web server start link. Yeah. So basically, a children. So this is the same thing as like a web server, and then that's basically what that's doing. Okay. And then the options are strategy 1-for-1, name. Yeah. And it probably doesn't make much sense here because you only have one child. But what is... If I go to erlang.org, guides. So the supervision strategy dictates what happens when one of the children crashes. 1-for-1 means that if a child dies, it will be the only one restarted. Okay. So if there are multiple children here, web server dies, and only the web server will be restarted. And where are the other strategies? Okay, supports many different strategies, and we will discuss them in this chapter. Let's scroll down a little bit. When they say they'll discuss them in this chapter, are they really going to discuss them? Where is it? It's in the next chapter. So in dynamic supervisors. Okay, so the two other strategies are 1-for-all and rest for one. So, okay, rest for one will kill and restart child processes which are started after the crash child. So I think I remember this. So if you have your children defined here, you can define multiple... What am I doing? You can define multiple... Like another one. And so on and so forth. Anyway, and then if the web server fails, then anything defined after that will be restarted. Okay. So our last option is to go all in and pick the 1-for-all strategy. The supervisor will kill and restart all of its children processes whenever any one of them dies. A completely reasonable approach for applications since the registry can't work without the bucket supervisor, and the bucket supervisor should terminate without the registry. All right, that makes sense. That was a interesting diversion, tangent, whatever. Anyway, finally create lib my app. myplug.ex with myplug module. And now run mix. Now run mix, run no halt, and it will start your application with a web server running at localhost 4001. All right. The plug.const struct. In the hello world example, we defined our first plug. What is a plug after all? A plug takes two shapes. A function plug receives a connection and a set of options as arguments and returns the connection. A module plug implements an init function to initialize the options, and a call/to function which receives the connection and initializes the options and returns the connection. Okay. As per the specification above, a connection is represented by the plug struct or plug.const. So this looks similar in Ruby or Ruby Rack to the env or environment. Not exactly, but close enough. Data can be read directly from the connection, also a pattern matched on. Manipulating the connection often happens with the use of the functions defined in the plug.con module. In our example, both put resp content type /2 and send resp /3 are defined in plug.con. Remember that as everything else in Elixir, a connection is immutable, so every manipulation returns a new copy of the connection. Yeah. Yep. Finally, keep in mind that a connection is a direct interface to the underlying web server. When you call send response /3 above, it will immediately send the given status and body back to the client. This makes features like streaming a breeze to work with. Plug.router. To write a router plug that dispatches based on the path and method of incoming requests, plug provides plug.router. And this looks very similar to sort of Sinatra way of doing things. Maybe? Maybe not. Or maybe it's... Oh, it seems sort of Sinatra-like. I'm more of a fan of the Rota way, which is a tree-based routing kind of thing. So, like, I don't have it on this machine, but like, if you route and whatever this is, and then you can do r.get, like some sort of path. Or r.in. Maybe it's r. I don't remember. Maybe it's r.on. Anyway, and then you could say r.get, and then do whatever you need to do here, and then r.post, and then the advantage of a tree-based or a routing tree rather than a routing list is that if I define like get foo, then that can be used here, like do whatever, and also here. I mean, I already have a video about this, so where I have a video about this where I explain all that, but that's why I prefer routing trees rather than routing lists. The router is a plug. Not only that, it contains its own plug pipeline too. The example above says that when the router is invoked, it will invoke the match plug, represented by a local imported match/to function, then call the dispatch plug, which will execute the matched code. Plug ships with many plugs that you can add to the router plug pipeline, allowing you to plug something before a route matches or before a route is dispatched to. For example, if you want to add logging to the router, just do plug dot logger. Note plug router files all of your routes into a single function and relies on the Erlang VM to optimize the underlying routes into a tree lookup instead of, oh, that's cool. Instead of a linear lookup that would instead match route per route. This means route lookups are extremely fast in plug. Pretty cool. But I wonder, like, would get something similar to this where this could be used further down the tree? I don't know. I'm just learning. This also means that a catch-all match block is recommended to be defined as in the example above. Otherwise, routing fails with the function clause error as it would in any regular Elixir function. Route needs to return the connection as per the plug specification. Okay. And testing, don't really much with that. Available plugs. Okay, so this one provides basic auth. It provides CSRF protection. Converts head requests to get requests, log requests. Overrides a request method with one specified in the request parameters. Parsers responsible for parsing the request body given its content type. Request ID, rewrite on session. SSL, there's static files and telemetry events. Okay, cool. Helper modules. And then I guess we're at the end of the page. No. Can't. Well, let me... I need to go to the next page. Okay, here we go. Plug can serve HTTP over TLS. Appropriately configured adapter. I don't want to read through all this. Self-signed certificate. Oh, that's cool. I mean, if I do deploy something like this on a web server, I probably won't. I probably won't use where is this? I won't use this EA issued certificate simply because there's already I would probably deploy it on I would probably deploy it on an OpenBSD server, and there's already HTTP. There's RelayD. So OpenBSD already has a pretty robust and secure web stack. So I'm not sure I need to use the Erlang VM for that. But maybe I should. Maybe it makes sense to have all of the entire web stack in the Erlang VM so that it can utilize Erlang processes. Yeah, I don't know how to. I can't really evaluate that yet without additional knowledge. I'll keep that in the back of my. I'll keep that in the back of my mind. A minimal HTTPS listener using plug.cowboy might be defined as follows. Okay, so we just defined the keys here, the certs, the full chain, stuff like that. Okay, this is pretty straightforward. There's also like Acme. The config. What is it called? Acme client. Okay. Yeah, there's an Acme client that already communicates with Let's Encrypt. And then you just update your what is it? You update their Acme, not update. Like I think there's let's see examples Acme client.conf. You update this, and you also update like e.conf and add this stuff here so that you can Acme challenges, and then you also add your certificates. So it's similar. Yeah. Scroll down here a little bit. Okay, that's the last page. Okay. Page reference. Oh, this is just okay. I'm not really sure what happened here, but I'm on Google now. How did that happen? Okay, whatever. All right, let's go back here. Search plug again. Yeah, here we go. Go to the online documentation. All right, let me check out the different web servers. So there's Cowboy and Bandit. There are no links to Cowboy or Bandit. I guess I'm gonna go here. Let's try it. Let's look at Cowboy first. Small, fast, modern HTTP server. Location page not found. That's no good. Where am I? Oh, 99s.eu/docs. Okay, here we go. Cowboy 2.10 user guide. Okay. Ration. Let's read this. Modern web. Cowboy is a server for the modern web. Well, I guess I won't read this entire thing. Erlang and web. The web is concurrent. Yep. Involved. Connections are opened. Requests are sent. Connections. The web page is displayed on your screen. Browser will only open up 4 to 8 connections to the server depending on your settings. This isn't much, but think about it. You are not the only one accessing the server at the same time. There can be hundreds, if not thousands, if not millions of connections to the same server at the same time. Even today, a lot of systems in production haven't solved the C10K problem. And the ones who did are trying hard to get to the next step, C100K, and pretty far from it. Erlang, meanwhile, has no problem handling millions of connections. At the time of writing, there are application servers written in Erlang that can handle more than 2 million connections on a single server in a real production application, bare memory, and CPU. I'd love to know the stats of the server in question. Like if we're talking about an AWS EC2 instance, are we talking about P2.micro, P2.small? I don't know. Probably not, right? That was pretty modest settings, so probably need like a beefy kind of machine here. But I have no idea. I have no idea. I need to evaluate that for myself. And I figure that out. Of course, various platforms need to scale beyond a few million connections. This is where Erlang's built-in distribution mechanisms come in. If one server isn't enough, add more. So basically, horizontal scaling. Erlang allows you to use the same code for talking to local processes or to processes parts of your cluster, which means you can scale very quickly if the need arises. Actually, that goes into kind of what I'll just open a new window. What I also want to develop. So there's there's this stuff like the basic web stuff, signing up users, collecting payments. Okay, collecting payments, admin dashboard, basically just ports. But I had an idea that I would want, if I have multiple servers, I would want them to connect to each other via, like, let's say we could call this under the infrastructure bucket. And I don't want to be tied to like Amazon or Google Cloud or Azure or whatever other cloud infrastructure there is. These are the main three. Like I could use DigitalOcean as well. But basically I don't want to be locked into one provider. But I still want servers on Amazon to be able to talk to Oceans. I was thinking I want to develop a way to automate doing this through, like, I don't know, WireGuard. So OpenBSD comes with a WireGuard pseudo device that you can use on configure through your hostname.if configuration file. But they don't come with a way to automate that. And there are solutions to automate that, but none that really work great with OpenBSD. So I want to develop like a hyper mesh, which automates WireGuard connection between a cluster of servers. Yeah, basically that. Not today. I was considering which language I would use to do that. Maybe, with Elixir. But I need to get a lot better at these languages before I even attempt something like that. And my basic idea was to do the most naive, dumb thing possible first. So like have a centralized server, and then each node on the cluster would contacts the central server. In WireGuard, you have a private key, a public key, and then a pre-shared key. You want like more, if you want even more security, I guess. Let's see. And so each node would generate their own private key, but then they would also publish their public key to the server. The server would let them know, hey, here are the other nodes or peers. So update your hostname.if configuration with this information, with this list of public keys, and I guess this list of pre-shared keys. I'm not really sure how I would do that, but maybe this will be like a V2 for a future. And then then every node on the hypermesh of the mesh network would be able to communicate with everyone else. Again, this is far in the future. I don't have the technical expertise to do this yet. So, anyway, why did I go off on that tangent? Oh, yeah, I guess this thing here. Okay. The web has large user bases, and the Erlang platform was designed to work in a distributed setting, so it is a perfect match. Is it? Really, you can find solutions to handle that many concurrent favorite language. All these solutions will break down in the next few years. Why? But firstly, because servers don't get any more powerful, they instead get a lot more cores and memory. This is only useful if your application can use it properly, and Erlang is light years ahead of anything else in this respect. Secondly, this is very opinionated. Secondly, today your computer and your phone are online. Tomorrow your watch, goggles, bike, car, fridge, and tons of other devices will also connect to various applications on the internet. Only Erlang is prepared to deal with what is coming. The web is soft real-time. What is soft real-time? It means we want the operations done as quickly as possible, and in the case of web applications, we want the data propagated fast. Comparison. Hard real-time has a similar meaning, but also has a hard time constraint. For example, an operation needs to be done in under n milliseconds, otherwise the system fails entirely. Users aren't that needy yet. They just want to get access to their content in a reasonable delay, and they want the actions they make to register at most a few seconds after they submitted them. Otherwise, they'll start worrying about whether it successfully went through. Okay. It will always run processes fairly, a little at a time, switching to another process after a while, and preventing a single process to steal resources from all others. This means that Erlang can guarantee stable, low latency of operations. Okay, I don't know if I will. This is interesting, but I don't know if I want to read all this right now. Okay, yeah, introduction. Always small, fast, and modern HTTP server for Erlang OT. Complete a complete modern web stack. Yeah, I just read that. Okay. What? Okay. This includes HTTP 1.1, HTTP 2, WebSocket, and server-sent events, and web machine-based REST. Cowboy comes with functions for introspection and tracing, enabling developers to know precisely what is happening at any time. Okay, it seems like it's a pretty mature product. Going to use the Erlang.mk build system. What is the Erlang.mk build system? Oh, this is GitHub. I don't know if GitHub works well with, yeah, it doesn't really work well with W3M or terminal-based browsers. Whatever. Flow diagram. Okay. Client accepted protocol stream. Middlewares. Okay. Server, this step is handled by a ranch acceptor. All right. The whole reason I was looking through this is because I want to evaluate the differences between Cowboy and Bandit. Oh, let me try Bandit now. Whoops. All right. A pure Elixir HTTP server built for plug and WebSocket apps. online documentation. As an HTTP server, Bandit's primary goal is to act as glue between client connections managed by Thousand Island. What is that? What is this? Thousand Island, a modern Elixir socket server. Oh, okay. Heavily. So it sounds to me like Cowboy uses this thing, Ranch. Oh yeah, it's written by that person. And it aims to be easy to understand and reason about, while also being at least as stable and performant as alternatives. Okay. Application code defined via the plug and or WebSock APIs. As such, there really isn't a whole lot of user visible surface area to Bandit, and as a consequence, API documentation presented here is somewhat sparse. This is by design. Bandit is intended to just work in almost all cases. The only thought users typically have to put into Bandit comes in the choice of which options, any, they would like to change when starting a Bandit server. Sparseness of the Bandit API should not be taken as an indicator of the comprehensiveness or robustness of the project. I don't know if I like just work libraries. Or another way to put that is auto magic. Wait. Auto magically. I don't know if I like that, but we'll see. Mostly because auto magic stuff or things that just work, quote unquote, or work like magic, obfuscate what's happening under the hood. I don't like that. I would rather just know and make it visible somehow. I don't know. Maybe not. I haven't really thought about it that much in a while, but on a gut feeling, I don't like auto magic stuff. Anyway, so if you're using it with Phoenix, you can add this using Bandit with plug application. Using Bandit to host your own plug is very straightforward. Assuming you have a plug module implemented already, you can host it within Bandit by adding something similar to the following: your application's application.start. So and probably update the web server to Bandit. So web server. Bandit. Plug. My plug. Then I don't need any of these other options, I suppose. Let's see. So I just run this by running Elixir webserver.ex. The module Bandit was given as a. Oh, I need. All right. I need to. This. And then resolving dependencies, installing, filing. Okay, now it's running on localhost 4000. Oh yeah, it's the same. But there's a lot less configuration. involved. Kind of, yeah. I mean, this is a very sparse example, so it's not really showing the real difference. I suppose. It's number of number of options are defined when starting a server. The complete list defined by the op. So, oh yeah, see here, there's a scheme similar to this. Suppose. Then you can also do your cert file and key file, but I don't see a way to like do like Acme style updates to your like communications to Let's Encrypt, because they don't go over it. Let's see, types. WebSockets, I'm not really interested in WebSockets right now. I'm just the basic HTTP right now. Okay, this definitely looks like documentation now. Is there a next page? No. Okay, I'll go back up here. Go back. Go to the GitHub. All right. Here we go. Here's the README. Same kind of stuff. Let's see. Same stuff as the documentation on Hex. Okay. I think that I'm at my limit. It's been about 2.5, almost 2.5 hours. And I've gone over a couple things. Like I went over a little bit of the Elixir getting started. I went over a little bit of getting a plug server started with either Cowboy or Bandit. Not a whole lot. I didn't expect to get through a whole lot today. I'll probably stream next week on Friday. And just go through this little by little till I actually have this stuff. I'll probably still be going through Elixir. But anyway, I guess that's it for today's hyperdevlog. And yeah, take care. Bye now.